Hello everyone, welcome to the lecture series of data structures. I am Amrit Kaur and I will be covering the topic insertion sort algorithm. Let us see through the contents first. I will be talking about the basic algorithm of insertion sort, then a solved example using the same, and then lastly we will be talking about the implementation of this algorithm using a C program. So talking about insertion sort, this is not the best sorting algorithm so far, but it is slightly better as compared to bubble sort and selection sort. In this, what we are doing is we simply have a set of elements present in a given array, and for those set of elements, what we are doing is we are simply dividing it into two parts or two sub arrays. One is the sorted array and another one is the unsorted array, as we were doing so far. For this, we first of all pick the first element, and that element is considered to be a part of the sorted array list because being a single element, it is sorted in itself. Then we start picking up the next element from the unsorted array, and we keep comparing it with the element present in the sorted list. After a series of comparison, so based on the condition that is being provided, we simply switch the element from the unsorted list to the sorted list, and the elements are shifted from the sorted list one position at a given time. So here is the pseudo code for the same. So now let us try to understand this code with the help of the example over here. First of all, we consider this particular example. We have an array in step 1. In this, we have certain list of elements. As the algorithm goes, we will first pick the first element, that is 7 over here, assign it to a variable, say value, as per the pseudocode. Now, this element becomes the part of the sorted array, being a single element itself, and the remaining elements are the part of the unsorted array. So what we are doing is, next, we simply pick up the element from the unsorted array list, that is the element number 8. Now, this particular element is compared with the element present in the sorted array. Now, we see that 7 is already less than 8, so we don't have to perform any shifting operation in this. So, we simply move this particular marker that divides the sorted array and unsorted array to a position in front. This is just a marker or a pointer to make sure that we have these set of elements that are already sorted and the remaining elements are unsorted. These will be noted with the help of the loops that we are using. Next, we have another element from the unsorted array list. Again, we pick up the first element present in the unsorted list, which is 5. We compare it with the element present in the sorted array list. So what happens is we compare the elements one by one with the position that is less than 5. That is, it is present at second index. It is compared with the element less than it, that is at the first index. So here 5 is less than 8. Again, it is compared with the element that was already present at this particular index. 5 is also less than 7. So 5 is shifted to the first position and the elements are shifted one position back. That is, 8 is shifted at the position where 5 was present. 7 is also shifted ahead and 5 is placed at the first position in the sorted array list. And the marker for the separation between the sorted and unsorted array list is also shifted one position ahead of it. Then again, repeating the same procedure, we'll pick up the first element in the unsorted array list. The element number is 2. It is compared with the element present at the position just before it. We simply realize the element 8 is obviously greater than 2. So what happens is 2 has to come before this. It will be shifted to a position later. Then 2 will be compared with 7 also. Now 2 is also less than 7. 7 will also be shifted backwards. 2 will come at the position of the 7. Now 2 is compared with 5. Now 2 is less than 5 as well. So for this case, 5 will be shifted a position back and 2 will come at the first position. And the marker will shift ahead. So here we see this, that the marker shifts ahead in the step number 10. Now again we pick the first element in the unsorted array list, which is 4. It is compared with 8. 4 is less than 8. 8 shifts backward and 4 moves towards this position. Then 4 is compared with 7. 7 moves backward. 4 moves ahead of one position. Then 4 is compared with 5. Now 5 also is greater than 4. 5 moves backward and 4 is placed at this particular position. 4 is compared with 2, but here 4 is greater than 2, so no shifting takes place here and 4 takes place the position at the first index. The marker is shifted ahead and the sorted array keeps on increasing one at a time and the unsorted array keeps diminishing at the same pace. So the next element we pick up is the element number 6. Element number 6 is simply compared again with the elements that are present in the sorted array list. 6 is less than 8, it moves one position ahead, 8 shifts back. 6 is compared with 7, 6 is less than 7, then 7 moves one position back. 6 is compared with 5, but 6 is already greater than 5, no further shifting takes place and 6 resides at this particular position where 7 is present. So we have this position in step number 3 where 6 resides. Now we will simply move the marker ahead. Finally, element left in the unsorted array list is 3. So what happens is 3 is compared again with the element that is present in the sorted side. That is, it is compared with 8. It moves ahead. It is compared with 7. It has moved ahead because it is less than 7. Then again, 3 is less than 6. 3 is less than 5. 3 is less than 4. But at this point, 3 is greater than 2. So eventually, 3 resides at the first index after 2, and all we have is the entire list which is sorted over here, and the unsorted list gets 0 or empty at this point of time. So this is our final list in step number 16, just how the insertion sort is performed. Now let us see the implementation of insertion sort algorithm. First, I have made the inclusion of all the necessary header files. Here I have stdio.h, then I have declared the main program. Following that, few declarations have been made initially. They are regarding the looping variable, some temporary variable, a count variable that I will be using, as well as the declaration of the array which is named as number. The maximum capacity of this array is specified to be as 25. The next statements are related to the user input, in which I'm basically asking the user to enter the upper limit of the numbers it wants to get sorted with the help of this array I have. The statements, that is this for loop followed by a scan, simply takes the input from the user in terms of the numbers that it wants to enter in the array. Now these numbers will be basically sorted in the steps to follow. Here from the line number 15 lies a main logic for the insertion sort. So what we have done is this loop begins from I equals to 1, because as I explained, the 0th number index will itself be considered as a part of a sorted array, and the remaining indexes from 1 to n minus 1 would be taken as unsorted list. So what it is doing, that it is taking the first number, that is the number present at the index number 1, and it is storing it in the temporary variable temp. Then for the other number that is present at the 0th index, which is denoted by j, that is I minus 1, is simply 1 minus 1, that is 0, refers to the previous number. Now this previous number refers to the sorted array list. Now these two numbers, that is the number present at the 0th index and the one present at the first index, are simply compared and checked for a condition. Now for the condition that is denoted by the while loop, this condition simply checks for the fact that if the number that is stored in the temporary variable, which amounts to be my first integer of the unsorted list, this number, if it is less than the number that is stored in the sorted array, if this amounts to be true, provided that the index number is greater than 0, then in that case what I will be doing is that I will be simply shifting the integers from the sorted array list to the unsorted array list, so as to make the space vacant for this unsorted number to reach out to its position in the sorted list. So this is the entire procedure that is taking place, and we are shifting the values one after the other, and once this is done, we will simply shift the marker ahead to denote that these particular numbers are the part of sorted list and the remaining numbers are the part of the unsorted list. So this condition keeps on taking place until and unless our numbers present on the unsorted side of the list are eventually greater than the numbers that are present in the sorted list. So this is the entire logic shown over here. The final steps are simply for printing out our sorted list of array elements as dictated by the condition as of the comparison operator. Finally, we have ended the program. Let us compile and see the results. The code is compiled and it does not show any error, so we can finally run the same code. So here, as per my input statement, it is simply requesting for the numbers I am willing to enter. Let us suppose I am trying to enter 7 numbers. Now this is my sorted list of array elements and the time that it has consumed for sorting these lists. So this was all about the execution of the insertion sort. Here are the few references. Thank you.